So chapter 9 is circles, and before we discuss the theorem and the problems, first let me explain to you the parts of a circle. So if I have a circle, normally the center of the circle is represented by O. If I join O to any point P on the circle, this becomes the radius. So radius is the distance from the center to the circumference. This is the circumference, right? If I extend this radius on the other side, then this becomes the diameter. So diameter is actually the longest chord. So this is the diameter because it is passing to the center, and diameter is equal to twice the radius. If I just draw AB, any 2 points on the circle, then when I join this, I'm going to get a chord. Now, a chord divides the circle into two parts. One is a smaller part, or there is a bigger part. The smaller part is called the minor segment. This is a segment. And this bigger part is called the major segment. So segment is the region between chord and this is called the arc. So if I'm going from A to B, here, this is called the minor arc. And if I'm going from A to B in the longer way, that is called the major arc. So we should be aware of these terms: radius, chord, diameter, minor arc, major arc, chord, minor segment, major segment, right? Then we have something called a sector, like a pizza slice. Okay, this is a sector, and the smaller part is called minor sector, and the bigger part is called major sector. The bigger part is the major sector, smaller part is the minor sector, right? And here the sector is the region between the arc and the two radii here, OA and OB, right? It is the region between the arc and the radii. So this is minor sector and major sector. So this is the introduction of the chapter. You can have fill in the blanks or 1 mark question based on segment, sector, chord, diameter, arc, etc. Now we go to the first theorem, that is equal chords subtend equal angles at the center. Equal chords AB and CD are equal chords. Question is, they subtend equal angles at the center. That means I have to prove that angle 1 equal to angle 2. AOB and COD have to be proved equal. For this, we will take the two triangles and prove them congruent. OA and OC are equal radii of circle. If you have a circle, all the radii are equal. OB and OD are equal. Again, radii of the same circle. AB equal to CD already given to us. Therefore, we can say the triangles are congruent by SSS, and therefore angle AOB equal to COD. So remember always, whenever we are having a circle, if we have two chords, equal chords, the angle made by the chord at the center will also be equal. So if AB and CD are equal, then angle AOB will be equal to angle COD. The converse of this will also be true, that if we have two angles subtended by two chords which are equal, so if the angles are equal, then we can say that the chords are equal. Converse of this, if angle 1 equal to angle 2, then obviously we can say that AB equal to CD. So this is the first theorem that can come with proof, and it's a simple theorem. Just prove the triangles congruent by SSS. Now we come to the first exercise. It has only 2 questions. The first question, recall that two circles are congruent. Now, what is the meaning of congruent circles? Two circles which are exactly equal. That means they have the same radii, right? Prove that equal chords subtend equal angles. So it is something like the theorem that we did. Of course, that was for a single circle. Now we are having two congruent circles. These are two congruent circles. Here we have the center as O, and here let us assume O dash. So what are we going to do? Prove the triangles congruent. Which triangles are we taking? Triangle AOB and triangle CO'D. OA equal to O dash C. Radius of congruent circles are equal. They are given congruent. If they are congruent, they are exactly identical. OB is equal to O dash D. Again, radii of congruent circles are equal. And it is also given that chords are equal. Prove that equal chords. AB equal to CD given. And once we have these three conditions, we can say that the triangles are congruent by SSS, and therefore, if triangles are congruent, I can say the angle subtended at the center, angle AOB, is equal to angle CO dash D by CPCT. I hope you remember what CPCT was, corresponding parts of congruent triangles. And question number 2, if you see, is the reverse or the converse of this. It's the converse of the question that we did just now. So we are going to do the converse, that is, prove that if chords of congruent circles are equal, if the chords are subtend equal angles at the center, that's again the conditions are going to be different. Proof is going to be almost same. What are we going to do? We are going to take the same two triangles. We draw the figure like this. We are going to draw the same figure. And once we draw the figure, you will understand now that if chords subtend equal angles, that means angle AOB is now equal to angle CO dash D. This is the only change that is happening. In the first question, we had to prove this. Now it is given OA equal to O dash C and OB equal to O dash D, because again, radius of congruent circles. Circles are again congruent. Now for the second part, we will say that triangles are congruent because of SAS. The first one was SSS. Now we have side, angle, side. And therefore, what can we say? Chords are equal. So if the angles are equal, then chords are equal. And this was if chords are equal, then angles at the centers are equal. Of course, they have to be congruent circles. Then only we can equate OA and O dash C and OB and O dash D, because only radius of congruent circles are equal. So that's the first exercise, 9.1.